Alright, so I think this is recording. Let's take a look at these problems from Skill 8C. They give us right triangles, and we're in right triangle trigonometry. By the Pythagorean theorem, let's find the length of this missing leg. It is going to be the hypotenuse squared minus the other side squared, and take the square root of that. 196 minus 144, probably 52. Let's check that on a calculator. 2 squared minus 12 squared. Yeah, 52. They do expect us to simplify radicals. The biggest perfect square that divides 52 is 4. 4 times 13 is 52. So I know that this side is 2 radical 13. So now with my SOHCAHTOA, I can get the 3 main trig functions. Well, I don't know if I want to call them main, but through SOHCAHTOA, it's the ones that people are most familiar with. It's not just sine, it's the sine of an angle, sine of theta. The opposite leg is 12. The hypotenuse is 14. Those are both even numbers, so that's 6 over 7. The cosine of angle theta, the adjacent leg over the hypotenuse. These are both even numbers, so this reduces the tangent of angle theta, the opposite leg over the adjacent leg, 12 over 2 radical 13. Those are both even numbers. I need to rationalize the denominator. Alright, so now for the other 3 ratios, we just take the reciprocal. The cosecant of angle theta is the reciprocal of sine. The secant of theta is the reciprocal of cosine. I need to rationalize that denominator. And the cotangent is the reciprocal of tangent. If I flip this one, I'll have to rationalize. If I flip the one before it, then I have the square root of 13 over 6. It'll just save me time. There's my 6 answers for problem 1. Let's go ahead and keep going. Here in problem, now I have to find the hypotenuse. So I know that hypotenuse is 30 squared plus 16 squared. And I don't know what that is. $11,056. Let's see, what's the biggest perfect square that divides it? So this is a perfect square then, because 17 squared is 289, and I divided it by a perfect square. So I can take the square root of 1156 and get 34. And so since all of these are even numbers, I can find a similar triangle. See, I didn't recognize it as a Pythagorean triple with it because they've scaled it up. They've multiplied it by some value. So the sine of 30 degrees, you know what, I can use a similar triangle. I can divide all of these by 2, and then that way I won't have to divide each individual fraction. I can say this is similar to a 15, 17, and 8. And see, 8, 15, 17 is a Pythagorean triple that you're probably more familiar with. The sine is 15 over 17. And see, I don't have to reduce that. The cosine, the adjacent side over the length of the adjacent side over the length of the hypotenuse, 8 over 17. The tangent of theta is the length of the opposite leg divided by the length of the adjacent leg. 15 divided by 8. I can take the reciprocal. The reciprocal of sine is cosecant, and that's 17 over 15. The reciprocal of cosine is secant, so that's 17 over 8. Reciprocal of tangent is cotangent, and that's 8 over 15. Let's go ahead and do the next one. To find the length of this missing side is the square root of the hypotenuse squared minus 12 squared. So let's jump to a calculator. What is 18 squared minus 12 squared? 180. And 180 breaks down to what? 2 squared times 3 squared times 5, 4 times 9. So 36 is the biggest perfect square that divides 180. So the square root of 36 times the square root of 5, because 36 times 5 is 180, and the square root of 36 is 6. So this missing side has a length of 6 radical 5. I'm going to erase this other part just so that I'll have room. And now for my 6 trig ratios, the sine of, you might put an h next to there, because if they twist this, you want to make sure that you pick the right ratios, the right side. From your SOHCAHTOA, your sine is the opposite side over the hypotenuse. So opposite to angle theta is 12. And you know what? Let's reduce all of these like I did last time. All of these are divisible by 6. So this guy can just be radical 5. This can be 2, and divide this by 6, and that's 3. And now I won't have to reduce all of these fractions. The sine of theta is going to be 2 over 3. The cosine of theta is going to be radical 5 over 3. The adjacent length of the adjacent side over the hypotenuse. The tangent of theta is 2 over radical 5, but you need to rationalize that, so you'll get 2 radical 5 over 5. The other 3 trig ratios are reciprocals to these, so sine of theta and cosecant of theta are reciprocals to each other. Cosine and secant are. And 3 over radical 5, I need to rationalize that. And the cotangent of theta is the reciprocal of tangent. So there's those 3 answers. Let's go ahead and do 4. We know from our days of geometry. Oh, I almost said 3, 4, 5, but look, that side is 5. Better slow down. The hypotenuse here is 3 squared plus 5 squared, 9 plus 25. That's the square root of 34. That there is no. That's just 2 times 17, so I can't reduce that radical 34. The sine of angle theta, that from my SOHCAHTOA, the ratio of sine of theta is the length of the opposite side over the length of the hypotenuse. I need to rationalize that. And 5 over 34 does not reduce, so there's my answer. The cosine of 30, the length of the adjacent side over the length of the hypotenuse. Rationalize that. The cotangent, tangent, well, I guess I could have done cotangent, but the tangent is the opposite over the adjacent. And now let's take the reciprocals, so the cosecant of theta, and I'm just going to take the reciprocal before I rationalized it to save time, because if I flip this and then rationalize it, it would reduce to this. The secant of theta, the square root of 34 over 3, and the cotangent of theta, 3 over 5. Alright, I'll stop there.